Hello everyone, welcome back. In this video, we'll be discussing about the last problem of today's biweekly contest, count k subsequences of a string with maximum beauty. The problem is very interesting and it can be solved in two different ways. Either you can use pure mathematics to solve this problem or you can use recursion. In this video, we'll be discussing both the approaches. If you are here just for one of the approaches, all the timestamps are there in the description down below. Feel free to skip to the particular section you are interested in. Having said that, I would encourage you to watch both the sections or both the solutions, because if you have the understanding of both the approaches, you will be able to use those things in the future contests as well. So with that, let's get started. The problem states that you are given a string s and an integer k. A k subsequence is a subsequence of s having length k and all its characters unique, right? Now the beauty of a k subsequence is the sum of fc for every character c in the k subsequence, and fc equals to the number of times the character c occurs in s. So for example, if s is 8 triple b double d, f of a would be 1, f of b would be 3, f of d would be 2, right? And if k is 2, so we need to find two subsequences or subsequence of length 2 such that all its characters are unique. So in this case, there are three subsequences of length 2, AB, AD, BD, and we can see AA or BB is not a valid 2 length subsequence because the characters are not unique. So we will simply find the beauty of these subsequences as f of a plus f of b, where f of a is 1 and f of b is 3. Notice this f of a denotes the count in the original string, not in the subsequent string, because in subsequent string characters are unique, so anyway f of a would be 1, so the value of beauty would not change at all. So the frequency is the frequency in the original string. Now we have to return an integer denoting the number of k subsequences whose beauty is the maximum among all k subsequences. Since the answer can be huge, we have to return it modulus 10 to the power 9 plus 7. So let's take an example. Let's say s is b double c a and k is 2. So in this case, we need to find out subsequences of length 2 with the maximum beauty, right? So let's figure out all the subsequences of length 2. So if you see, b c is one valid subsequence because it contains all the distinct characters. Then this b and this c is a valid 2 length subsequence, again 2 distinct characters. This b and this a is a valid 2 length subsequence. This c, this a, another valid subsequence, and last this c and a is another valid subsequence. Notice that c and c is not a valid subsequence because it doesn't contain only unique characters, right? Now if you find out the beauty of each of them, the beauty of this would be f of b plus f of c, where f of b is the frequency of b in the complete string and f of c is the frequency of c in the complete string. F of b will be equals to 1 because b occurs exactly once in the original string, and f of c would be 2 because c occurs twice. So the beauty of this particular subsequence bc is 1 plus 2, which is 3. Similarly, beauty of this one would be f of b plus f of c, again 3, and so on and so forth. Now we want maximum beauty. So if you can see maximum beauty is 3, and there are 4 subsequences which have the value 3 or which have the beauty 3, and hence the answer here is 4, right? So we have to count the number of subsequences with the maximum beauty. So hope the problem statement is clear. Now how to solve this? So let's assume that this is your s and these are the values of f. So basically f of a denotes the number of times a occurs in the original string. So f of a here is 4, and similarly f of b here is 1, f of c is 2, f of d is 3. Now we want to maximize the beauty, right? We want the number of subsequences which have the maximum beauty. So we want to maximize the beauty. In other words, we want to select 2 characters such that their summation of f is maximum possible. So in this case, we want f of x plus f of y or you want to select two things x and y such that f of x plus f of y is largest possible, right? And x can be anything between a, b, c and d, and similarly y can be anything between a, b, c and d. Now if you think about it, which two will you pick? So x should be this and y should be this. Simple. Why? Because you want to maximize this, so you will just pick the two with the largest value. You can try out any other combination, you will see the beauty or the summation of these two will always be greater than summation of any other two in the array. So the logic is simple. We want to maximize the beauty, we will simply pick the largest k element in the f array, right? So in this case we know that the subsequence will contain a and d. Now which of these a subsequence will contain or which of these d subsequence will contain will determine the number of subsequences, right? So let's say you take this a and this d, so this is the one valid subsequence. Similarly you take this a and this d, so this is another valid subsequence. Similarly you take this a, this d, another valid subsequence, right? So basically for every a you can pick any d and it will form a valid subsequence. Similarly for second a you can pick any d and it will form a valid subsequence, right? So if you think about it logically, it is you have to take one a and one d, you have total 4 a's to pick from, you have total 3 d's to pick from. So number of ways in which you can pick one a and one d is 4 into 3, which is 12. So this is the total number of subsequence that will have the maximum beauty, in this case 7, right? So that's the logic. The logic is simple, just sort the array, take the largest k and then multiply their frequencies, right? So if you look at the pseudocode will something like this. We will simply figure out the frequencies, sort the frequencies, right? And then we will pick the largest k from those frequency array starting from 25 up to 25 minus k, and we will just multiply their frequencies and this will be our result, right? Now this is fine, but what if we have collisions? In other words, in the previous case we had every frequencies as equal, so there is just one way to get the maximum beauty, which is 7, right? So there is just one way to get the maximum beauty, which is f of a plus f of d. But there can be scenario where there are more than one ways to get the maximum beauty. So again in this particular example k is 2, so we need to pick two things from here. But in this case you can see f of a plus f of b is giving you a beauty of 7, right? Similarly f of a plus f of d is also giving you a beauty of 7. So we have to now pick which of these two will be there in our subsequence, or in other words we have to figure out the number of subsequences with f of a and f of b, and we have to figure out number of subsequences with f of a and f of d. So with just 2 character it is simple, but let's say there are 10 characters, right? And we have 10 3's. So in this case let's say this is also 3. So in this case there are total 3 choices now, right? F of a plus f of b, or f of a plus f of d, or f of b plus f of d. All of them will give you the maximum beauty. So you need to figure out the maximum, figure out the number of subsequences possible with these combinations, right? So here comes the diversion. So this problem basically select one from the given 2, or number of subsequences that is possible if we select one from the given 2 is or can be solved using combinatorics, or it can be solved using pure recursion as well. So let's start with the mathematics approach first, and then we'll look at the recursion approach as well. So what's the problem? The problem statement is, given an array, for simplicity, let's assume that this is C, right? So basically this is now 2 and this is 3. So this is just to make things a bit more concrete. So in this case, what we know is, we know that there are 3 threes, or basically the number of the frequencies of the last element, or the greatest element. So we have to pick 2 of them, right? Now the frequency of this element is actually repeated thrice here. So the frequency of second largest element in this particular array is 3, and 3 is repeated thrice, right? So in this case, we need to now pick which of these 3, A, B or D, we will pick in our subsequence. All of them will be valid. So we need to figure out how many exact number of subsequences are there which we can form, right? So in other words, the problem statement is, we have 2 spaces, right? We need to fill these 2 spaces. We have 3 choices, either A or B or D, right? Now you can say, okay, first of all you need to figure out which of these 3 will come in these 2, right? So how you can figure out this? It's simply, you have 3 choices and 2 spaces, so it's 3C2, right? So these are the number of ways in which you can pick 2 of them, right? Now once you have picked 2 of them, let's say you have picked A and D, so you know A will come here and D will come here. So what you need to do now, you need to find the frequency of A, find the frequency of D, and multiply them, right? That's what we have done previously as well. So this you have to do for A and D, and let's say second time you choose A and B. So in this case, you have to pick now f of A plus f of A multiplied by f of B, right? And in the same fashion, if you pick B and D, it will be f of B and multiplied by f of D, right? So basically, depending on which 2 you are choosing, the value is changing, f of A into f of B, f of A into f of D, and similarly here f of B into f of D, right? So you can't simply say, okay, I will figure out the value of 1 and multiply it with 3C2. That might not be the correct result. But in this case, f of A multiplied by f of D, f of A multiplied by f of B, and f of B multiplied by f of D, all of them will be equal. Why? Because if you think, only the last element can be the one which can have multiple choices. So for example, let's say you have multiple elements, right? Let's say K is 10. So you have 10 you have to pick 10 elements from here, right? Now you pick something. If you see only the last element, let's say last element is 3, so only this 3 can be the problematic one. The first one, let's say, is 5, second one, let's say, is 4, and then there are few more 4s, right? And then there are number of 3s. So only the last one can be problematic, because all others are something you need to take. There is no other choice. If you don't take 4 and take any other thing afterwards, it will lead you lesser beauty, right, or lesser sum. So only the last one is problematic. So whatever choices you need to make, you have to do for last one only, right? And because that's the case, f of A would be equals to f of D, f of A would be equals to f of B, and f of B would be equals to f of D. So all of them are actually equal, because they all would be equals to the value of the last one, because that's what is something we have choices for. So what we will simply do, we know that all of them has equal values, so we will not pick and choose them. Instead, we will just find the value for 1. What will the value for 1? Value for 1 will be 3 power k dash, where k dash is k minus number of unique ones which we have already taken, or number of numbers which are greater than the last one, right? So in this case, if k is 8, so k dash would be 4, because 4 is you have already taken. You just have to take care of the remaining 4 elements which you will put. So this summation or this multiplication value would be 3 power k dash. Now this 3 power k dash will occur 3 C2 times, right? So basically you will just multiply this with 3, or not 3 C2, basically in this case there are 4 choices, right? So 4 C4, right? So just to reiterate this entire thing, what we are doing is we wanted to figure out how many choices are there for the last, or how many ways are there in which we can fill the k places, right? And we saw that we have to pick the ones which are on the higher side. Only the last one, if k, let's say k is 8, so only the last one is the one which can be repeated, and we need to take care of combinations for that. So let's say in this particular case k is 8, right? Let's assume this. So k is 8 and this is the configuration, and there are few more 3s as well. So in particular there are 6 3s and k is 8, and there are 4 numbers that are greater than 3. So in this case, you know that these 4 you have to take no matter what. So first 4, let's say you have to fill 8 places. So 4 places is something which is already filled. Now you have remained with 4 places, and in these 4 places you have 6 candidates, right? So you have to pick 6. You have to pick 4 candidates out of 6. So 6C4 is the number of choices you have, or number of ways in which you can pick 4 candidates out of 6. And for each of these 6C4 candidates, you know the value would be 3 power 4. So you will just multiply with them, right? And that will be the final result for the remaining 4 places. So you know how many ways are there to fill the remaining 4 places, and you already know the number of ways to fill the previous 4 places, 5 into 4 into 4 into 4. So you will simply multiply this number with this number to get the answer, right? So if you don't understand this, I would encourage you to rewind and watch the previous 1 minute of the video. I'm sure you will be able to get it. So this is how the pseudo code would look like. If you think about it, this entire thing is still the same. We are just sorting the frequencies and picking the largest k. Now only thing that we have changed here is, instead of multiplying everything, or instead of picking all the k elements, we will skip the last element, right? Because we know that only the last element can be repeated, or it's something that we need to take care of. So we'll skip the last elements, and once we have done this, we will count the number of elements which are equal to the last element, right? And we know there are this many 3s. If I compare it with this example, we know there are this many 3s, and we know these are the remaining number of places that we need to fill up. So in this case, we know that there are taken would be 4 in this particular case, right? Because we have filled 4 places, and k minus taken would be 4 because we need to fill the remaining 4 places. And same would be 6 because we have 6 3s, or 6 numbers, or 6 alphabets for which the frequency is equals to the 8th largest element, right? Now what we will simply do, we will simply take nck, where n is this same number and k is k minus taken, right? So we have to choose these many out of this, right? Once we have figured out that, we will simply multiply it with f of k minus 1 power k minus taken. Basically this is the frequency of the last element, so everything would be equals to this. We will just simply take so every of these number will have frequency of 3. So number of ways in which I can pick this particular choice would be 3 power 4. So, and we know that there are 6C4 ways to choose which 4 element to pick to fill in, right? So this is the total number of ways. So hope this entire session makes sense. The only thing that you might be thinking of is how we can figure out this thing efficiently, NCK, because others are straightforward. We know that f of k minus 1 power k minus taken can be done efficiently, because uh, k and taken both is 26. So basically you can also do this efficient. You have to divide here, but there is no division here, there is only multiplication here. So this can be done using simple multiplication, k minus taken times, and k minus taken would not be greater than 26. So this all things will be fine. Now only thing that remains is how to figure out the value of NCK, and for that, you know that this is the usual formula for NCK. The actual trick here is to figure out 1 by k factorial and 1 by n minus k factorial. So this inverse fact denotes the value of 1 by k factorial modulus m and 1 by n minus k factorial modulus m, right? Now how to figure out this? This can be figured out using Fermat's little theorem. If you look at Fermat's little theorem, a power p is congruent to a mod p, right? In other words, if you see, a power p minus 1 is congruent to 1 mod p. So if you take a power p minus 1, it will be it will leave remainder of 1 when divided by p, right? So if we will use the exact same theorem, a power p minus 1 congruent 1 upon p, if you just divide a by both the side, a power p minus 1 by a congruent 1 by a mod p, and if you just take the powers, a power p minus 2 is congruent to a power minus 1 mod p. So this is what we have. 1 by a is actually equals to a power minus 1, and we already know that a power minus 1 is actually congruent to a power m minus 2 mod m. So if you remember, this was just the modulus in the power. So we have modulus m, so this is a power m minus 2. Only thing for Fermat theorem to be applied is that a and p should be co-prime, right? If a and p is not co-prime, this theorem is not applied. In this particular case, a and p is actually co-prime, because p in this case is a prime number itself. So 10 to the power 9 plus 7 is a prime number. So because p is prime itself, whatever a can be, it will be not divisible, or it will be co-prime to that. So because a and m are co-prime, this theorem is applicable. So what you will simply do, inverse fact of n would be the actual factorial of n power m minus 2, right? And once you have figured out the value of inverse fact of n, figuring out inverse fact of others would be straightforward. Basically, you know the value of 1 by n factorial. So to figure out the value of 1 by n minus 1 factorial, what you will simply do is you will multiply this with n. This will give you 1 by n minus 1 factorial. That's what we have done. To figure out the value of j, we simply multiply the value of j plus 1 with j plus 1, right? So once you have done this, you will have inverse fact of everything. We will just simply multiply these three values and take it modulus m, and we will get the value of NCK as well. So this part can be done using fast exponentiation, because m here is 10 to the power 9 plus 7, so you can't actually keep on multiplying fact of n 10 to the power 9 times. That will not work. So you have to use fast exponentiation here. We have discussed fast exponentiation previously in the channel as well, but it's a very simple trick. You can use that. So these all things are there if you want to solve this problem using mathematics. But as we discussed, the problem can be solved using pure recursion as well. So next we'll be looking at that. So if you remember, we stopped at this particular case where we have some choices to make and we have to fill only 2 characters. So we have only 2 characters to fill, but we have 3 candidates that are willing to take these positions. So in other words, from 3 characters we need to take 2 characters. So if you think about it, every character will either be present or not present, right? So either A will be here or not here. So if A is there, what you remain with? You remain with 2 characters and 1 position. If A is not filled or if A is not utilized, you remain with 2 characters and 2 position. So don't you see the recursion here? Basically, for the first problem, the problem is give me the number of ways in which I can fill, give me the number of subsequences in which I can fill these 2 characters with one of these 3 characters, A, B and D. Now the reduced problem is give me the number of subsequences in which I can fill 2 characters from this remaining 2 characters. Or if you take A, give me the number of ways in which I can, if you fill A here, give me the number of ways in which I can fill this 1 character from this remaining 2 characters, right? So hope you can see the recursion here. We can simply use the recursion to solve this problem. So basically we want to have a function that can give us, given a character and number of remaining characters to be filled, give me the number of subsequences that in which I can fill these many characters from these starting from this character, right? So if you think about it, either you will pick CH or you will not pick CH, right? If you pick CH, the number of characters that you remained with is starting from CH plus 1 and you have K minus 1 more things to be filled out, and because you have taken CH already, so basically you have, let's say, 3 positions in this case, you know you have taken A here, or you are saying that I will pick A for sure. So if you pick A for sure, then you know that this will be filled with 3 characters, or there are 3 ways to populate this A, right? So what you can simply do is you can simply multiply it with frequency of CH, right? So this is what will happen if you pick the current character for the current position. If you don't pick the current character at all, then you will simply say give me the number of ways in which I can pick the remaining K characters from the remaining characters, right? So you will simply add these 2 up, and this will give you the value of this, right? So the pseudocode for this would look something like this: f of CH and K. Again, it's exactly similar to what we have discussed. Either you will pick the character or you will not pick the character. If you pick the character, you will if you don't pick the character, basically you are saying that I have to fill the remaining K characters with the remaining character that I have. Otherwise, if you put the CH at the current place, then you are saying I will be remain with K minus 1 characters from hereafter. So give me the number of ways or the number of sequences in which I can fill up these many characters, K minus 1 characters, with these remaining characters. And because I have filled the current character with current position with the current character, I will simply multiply it with the frequency of the current character. Sorry, it will be frequency of CH. So I will simply multiply it with the frequency of CH. And the base cases are simple. If we have exhausted all the characters, we will simply check if we have any more characters to be filled. If we have more characters to be filled, it means we have more characters to be filled, but there is no more character remaining. So we will simply return 0. Otherwise, we will return 1. If K is less than 0, it means we have done something wrong here, such that K becomes less than 0. So in this case, we don't have any ways at all to fill less than 1 characters, right? So hope this entire thing would run in 26 square, because the maximum value of CH is 26, number of characters 26, and K is also 26, because in worst case all the 26 characters would be equal. So you will have to fill 26 positions, or you will have 26 positions that will contend with each other. So K is 26, CH is 26. So total number of different states or different ways this F can be called with is 26 square. Now inside each state, what you are doing, you are simply doing some linear time operations. So this is order 1. So entire complexity is order 26 square, which is very small for the given time constraint. So hope both the solutions are clear. Next, we're looking at the code for both the solutions. I would encourage you to code both the solutions by yourself, because that's the point where you will understand the things that you don't understand while watching the video. So I would strongly encourage you to pause and try to code the entire thing by yourself. So the code is straightforward. We are finding out the frequencies of f, and we will simply see how many distinct characters are there. If number of distinct character is less than k, then we will simply return 0, because there is not enough distinct characters to be taken. Otherwise, we will simply sort the frequency and pick the largest k. And remember, we will skip the k minus, we will skip the characters which are contending with the k minus 1th element, or k minus 1th largest element. So we will skip all of them and we will multiply others with result. Now after that, we know that we only care about those elements which have frequency equals to f of k minus 1. So I have just made others as 0, because we don't care about any of them. So if you think about this, we only care about the one which have frequency 3. So we don't care about this c at all. So I just either you remove it, or you can simply mark the frequency as 0. Both will work. So in this case, we mark the frequency as 0. After marking the frequency as 0, we will simply we have two choices. Either we can use combinations, or we can use recursion. If you use recursion, you have this recursion function that takes in two things: the characters you need to start with, and the number of remaining spaces that you need to fill. So this is the number of remaining spaces that you need to fill, and this is the number of characters, the starting character that you can start with. And if you don't do this recursive way, you can also do the combinatorics way. Basically, you can count the number of same characters and then simply do nck of same nk minus taken, and then multiply it with f of k minus 1 power k minus taken, because all of them will have the same frequency, which is equals to f of k minus 1, right? So let's look at the functions one by one. So first hour I am not going through right now. Count subsequence is basically the recursive function that will give you the number of subsequences for filling up these k spaces starting from this character, right? So what we have done, we will either take this character or not take this character. If we don't take this character, we need to fill all the spaces starting from the next character. If we take the character, we need to fill k minus 1 remaining spaces starting from next character, and we have filled the current space with the current character. So we simply multiply it with the frequency of current characters, and we'll add them both up and take the modulus to get the value. Now nck is also straightforward, as we discussed. This is how we are finding out the factorial of n, and after finding the factorial of n, we simply find the inverse factorial of 26, which is equals to fact 26 power mod minus 2, based on the Fermat's little theorem that we discussed. After that, we simply figure out the inverse factorial for rest of them by simply multiplying with j plus 1. Once we have find out the inverse factorial, nck would simply be factorial of n multiplied by inverse factorial of k multiplied by inverse factorial of n minus k. So hope this entire solution makes sense. If you have any doubts in any of the two solutions, feel free to post them in the comment section below, and I will see you in the next one. Thank you.